In this video, what we are going to look at, we are going to look at two different kinds of problems. One is what is the number of whole number solutions of an equation like this, 2x plus 3y equals to 50. That is first thing that we are going to solve, and if they modify this number, how can we go and solve it? And if they modify this 2 and 3 into a different number, how are we going to solve it? Second thing we are going to learn is what is the highest number that cannot be expressed in 2x plus 3y format. So these are the two concepts that we are going to learn in this video. Let's enter into concept number 1. Question number 1. Question number 1, what do we have? 2x plus 3y equals to 50, number of whole number solutions. Now, let's go with extreme values. Let's assume y equals 0. There is no y that is contributing. Now, how many what is the value of x that I can go and substitute here so that the sum adds up to 50? I can go and simply substitute x is equal to 25, and I will get 2 times 25 plus 3 times 0 will add up to 50. So the condition is satisfied. Now, if I go and substitute y equals to 1, will I get a solution? I will not get a solution. Let's go and check how I will not get a solution. If I go and substitute y equals to 1, what I will be getting is, I will be getting 2x plus 3 equals to 50 or 2x equal to 47, whatever whole number value I go and substitute for x, I will not be able to get, because x is equal to 47 by 2, which is 23.5, which is not a whole number. So there is no whole number solution here. If I go and substitute x is equal to 2, let's see what I am getting here. I am getting 2x plus 6 equals to 50, or 2x is equal to 44, or x is equal to 22. I am getting a solution. And you will see that the pattern keeps repeating for every two values of increase for y. Y equals to 3, if I substitute, what I will get is 2x plus 9 equals to 50, which is not possible. 2x is equal to 41 will not give me a x is equal to 41 by 2, which is 20.5, which is not an integer solution. So there is no solution here. But y equals to 4 will give me a solution. Y equals to 4 will give me 2x plus 3 4s are 12 equals to 50. Therefore 2x is equal to 38. X is equal to 38 by 2, which is equal to 19. And did you notice there is a pattern here? The pattern is the coefficient of x is 2, y increases by the same value 2. It keeps increasing by 2. The coefficient of y is 3, and x, did you see, it gets decreased by 3 so as to get subsequent values. And there's a very good reason why this happens. The reason is every time I increase 2 values of y, there is an increase of 2 3s are 6 is getting increased here, and to offset the 6, x should be decreased by 3, so that 2 into minus 3 will give me minus 6. So here every time plus 6 gets added, here minus 6 gets minus 6 gets added. So what will happen is the balance will maintain and the sum will stay at 50. And from here, whenever I add 2 values for y, what I am doing is 2 into 3, 6 is the sum that I am adding here. And whenever I am subtracting 3 values from x, 2 into minus 3, minus 6 is the arithmetic change that I am bringing here. So what will happen is essentially the sum will remain unchanged, and I will get the answer is 50. So I can keep continuing this until x reaches the last positive value. So I can keep reducing x by 3. So x, if I keep reducing by 3, this will give me a value of 16, and x is equal to 13 divided by, reduce it by 3, subtract it by 3, x is equal to 10, x is equal to 7, x is equal to 4, and x is equal to 1 is going to be the last value. Beyond this, if I go, it will enter into the negative zone, and there will be infinite possible solutions in the negative zone. Let's not enter there. Similarly, I should keep increasing it by 2. So y, if I increase this by 2, this is going to be 6, this is going to be 8, this is going to be 10, this is going to be 12, this is going to be 14, and this is going to be 16. At any point of time, if you are not very sure if you have done it correctly or not, do a quick substitution there and we can verify it. So if I go and substitute this in our equation, 2 into 1 plus 3 into 16, what is this? This is 2 plus 48, and it is equal to 50, and therefore we have got our solution. So the number of whole number solutions would be 1, 2, 3, 4, 5, 6, 7, 8, 9. All the way from y equal to 0 to y equal to 16. So there are 9 solutions here. 9 whole number solutions here, and this can be done for any other kind of problem as well. Instead of 2x plus 3y equals to 50, you can, this problem can be slightly reworded as, let's say question number 2. We have 2 rupees coins and we have 3 rupees coins, and we need to form 50 rupees value. You only have 2 rupees coins and you have 3 rupees coins. You have enough 2 rupees coins and you have enough 3 rupees coin, and using these can you form 50 rupees coin? Yes. The first logical solution that I would be thinking is, like, without 3 rupees, let me take all 25 as 2 rupees coin and none of them as a 3 and no 3 rupee coin 3 rupees coins. And now the next step would be, I'll keep reducing 3 here and I will keep adding 2 here. So if I do that, what I will get is 22 2 rupees coins and 2 3 rupees coins. And if you why is this working? Because the reduction in value here is from 25, if I reduce to 22, there is a 3 2 rupee coin I am removing. So the value that gets removed is minus 6 rupees, which is exactly offset by the 2 3 rupee coin that I am bringing into picture. So the minus 6 rupees that happens here and plus 6 rupees that happens here will nullify each other, and the sum will remain 50, and I can keep going all the way until x is equal to 1, which is 1 2 rupee coin and 16 3 rupee coin. And this problem is exactly same as this problem. How many different ways can you form 50 rupees from 2 rupee coin and 3 rupee coin? The answer is, once again, 9 different solutions are possible. Let's go ahead and solve one more problem in this particular method. So how many solutions are there for, let's say I have 3 rupees coin and I have 5 rupees coin, and I need to form, let's say, 100 rupees. How many solutions are there? I have 3 rupees coin and I have 5 rupees coin. I have enough 3 rupee coins. Don't worry about the count. I have enough 5 rupees coins, and using the combination of 3 rupee coin and 5 rupee coin, I need to form a 100 rupee coin, 500 rupees value. How many different solutions are possible? This question is exactly same as number of whole number solutions of 3x plus 5y equals to 100. So irrespective of how the question is worded, we are going to solve the same thing. Now, the first thing that I can go ahead and try to do is, like, find an extreme value. For example, here if I go ahead and give all 100 rupees from 5 rupees coins itself. So what I will tell is, I will take 25 rupee coin and 0 3 rupees coins. And what I am going to do further is, because this is 5 rupees coin, and I will offset it by, I will remove 3 of these coins, and then I will add 5 of these coins for my next solution. Why am I doing this? So that I will get my next possible solution. So if I remove 3 of this, what I will be getting is 20 minus 3, 17 5 rupee coins, and 0 plus 5, 5 3 rupees coins. And the next solution would be, this is 14, then next solution would be 11, the next solution would be 8, the next solution would be 5, and the next solution would be 2. Beyond this, we don't have. And right now only we can go ahead and see that 3 plus 4, 7 possible solutions are there. We can stop right here, but we will not do that. We will still go ahead and verify if our answers are correct. So this is 5 and this is plus 5. This will give me 10, plus 5. This will give me 15, plus 5. This will give me 20, plus 5. This will give me 25, and plus 5. This will give me 30. We'll go ahead and verify it if whether this particular last solution is correct. If this is 30 into 3 rupees coin will give me 90 rupees value, 2 into 5 rupees coin will give me 10 rupees value. So when I add them both, what I have here is 100 rupees value. So these are the 7 possible solutions that I have. I don't have to go ahead and solve the entire thing. As long as I understand that the first value of 5 rupees is 5 rupee coin count is 20, I can keep subtracting it by 3 until it does not reach negative side. So, and that will be the number of solutions that we'll be having. So here the number of solutions would be 7 possible solutions. So this way, once you identify one possible value, and it doesn't even have to be an extreme value, that is the beauty of this problem. Even if you randomly find one middle value, from that you can go upward and you can go downward also, and you can find both the extreme values. In one extreme value, this will reach the last positive non-negative value. In another extreme, this will reach the last non-negative value. So we can easily know where to stop. Otherwise, if I keep going further in this direction, this will become negative. If I keep going further in this direction, this will become negative, and we know that is not possible because it's a whole number solution, because number of coins cannot be negative and all. So now we have learned how to solve the first type of problem, the number of whole number solutions of 2x plus 3y equals to 50. How can I go and solve? Now the question is, can every number be expressed in every number 50, 49, 48, all these things be expressed in 2x plus 3y format, or are there numbers that cannot be expressed in 2x plus 3y format? And what is, if so, then what is the highest number that cannot be expressed in 2x plus 3y format or any number format? So let's say for example, if I take a number like I'll take a bigger number, like let's say 3x plus 4y. Can we express every number in 3x plus 4y format? There may be some numbers which we won't be able to express in 3x plus 5 format. For example, a number 5 cannot be expressed in 3x plus 4y format if I use whole number values for x and y. Can I express 5 in terms of 3x plus 4y? I cannot do it. This is as good as saying that I have enough 3 rupees coins and I have enough 4 rupees coins. Can I arrive at 5 rupee coin value? I will not be able to do that. Okay. So now how can I identify this? Is there any solution to it? So now let's go and arrange these numbers in either, let's go and arrange all the natural numbers in 3 column format or 4 column format. Let's say this is 1 rupee value, 2 rupee value, 3 rupee value, 4 rupee value, 5 rupees, 6 rupees, 7 rupees, 8 rupees, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There is a reason why I am expressing it in this format. Now, let's go ahead and use, I have expressed in 4 format. So, let me start with 3 rupees coin. So, if I just use one 3 rupee coin, what is the value that I can go ahead and easily establish? I can go ahead and count 3 rupees using 1 3 rupee coin, or 6 rupees using 2 3 rupees coin, 9 rupees using 3 rupees coin, and 12 rupee using 4 3 rupees. Now if you had noticed, what we have got is we have filled every value. We have filled at least one value in each of the columns, each of the 4 columns. In each of the 4 columns, I have at least found one value that I can express using 3 rupees. So in the first column, I can express 9 rupees using 3 rupee coins. In second column, I can express 6 rupees using 2 3 rupee coins. In the third column, I can express 3 rupees using just a single 3 rupee coin. And in the fourth column, I can express 12 rupee using 4 3 rupee coin. Why is this important? Because anything beyond this numbers are 100% possible. The reason being, here how many 3 rupee coin did we take? We took 1 3 rupee coin, 2 3 rupee coin, 3 3 rupee coin when we were able to express this 9 rupees, right? Now add a 4 rupee coin and you will be able to express this. Add one more 4 rupee coin and you will be able to express this. Add one more 4 rupee coin and you will be able to express this, which means once you establish a number 9, every number in this column can be established. Can be expressed in 3 and 4 multiple format. Similarly, let's go to the second column. Here, how did I express my 6 rupees? Using 1 3 rupee coin and one more 3 rupee coin. So, using 2 3 rupee coin, I was able to express 6 rupees, right? Now, add a 4 rupee coin to the mixture and you will be able to express this. Add one more 4 rupee coin to the mixture, you will be able to express this. Add one more 4 rupee coin to the mixture, you will be able to express this. And which means every number in this particular column after 6 can be expressed in 3x plus 4y format. Same thing applies here also, and same thing applies here also. What about these numbers? Can I not express all these numbers? Don't worry about it. This is a fourth column. Every number is a multiple of 4. So which means not just 12, 16, 20, even 4s and 8s can be expressed purely using 4 rupee coin. 1 4 rupee coin, 2 4 rupee coin, 3 4 rupee coin, etc. That is more than enough and we will be able to express. So what are the numbers that are not highlighted here? 1, 2 and 5. These are the numbers I will not be able to express using a combination of 3 rupee coin and 4 rupee coin. What is the highest number that cannot be expressed? 5 rupee coin. So therefore, the answer for this question is 5. Now, we did it in 4 columns. Now the question that you might have is like, is it possible? Okay, why did I have to go with 4 columns? Can I do the same problem with 3 columns also? Yes, it is possible. Let's go and try that approach as well and we'll still get the same answer. 1, 2, 3 rupees, 4, 5, 6 rupees, 7, 8, 9 rupees, 10, 11, 12, 13, 14, 15, 16, 17, 18. Let's say I write all the numbers in 3 columns. And now let's pick up 4 rupee coin and let's see what are the columns that I can go and fill using 4 rupee coins. 1 4 rupee coin will I will be able to measure 4 rupee value. 2 4 rupee coin I will be able to measure this. 3 4 rupee coin I will be able to measure this. At this point of time I have filled at least one value in all my columns. Now the advantage of I have used 4 rupee coins to reach here. Now beyond this I can use 3 rupee coins to reach every value in each of the columns. For example, how did I arrive at this 4 rupees value? I used 1 4 rupee coin. And for any other value in this column, just keep adding 3 rupee coins one by one, and you will be able to express all the numbers in that particular format. Similarly, how did I arrive at this 8 rupee coin? By using 2 4 rupee coin. Add 1 3 rupee coin and you will get 11. Add one more 3 rupee coin and you will get 14. Add one more 3 rupee coin and you will get 17. Similarly, how did I arrive at this 12 rupee coin? I have used 4 plus 4 plus 4, 3 4 rupee coins. So beyond this, keep adding any 3 rupee coin and each 3 rupee coin will establish one more value in this particular column, which means every value, subsequent values in this particular columns can be expressed in 3x plus 4y format. What about the rightmost column? Don't worry about that because we have a 3 rupee coin and all these numbers are 3 multiples. So all these columns also can be established using just 3 rupee coins. So now what are the numbers that cannot be established here? 1 rupee coin, 2 rupee, 1 rupee value, 2 rupee value, 5 rupee value. The same thing that we already got using this particular previous method where we used 4 columns and then we filled using 3 rupee value. Here we in the rightmost scenario we are using 3 columns and then we started with filling 4 rupee coins. So this way we can go and try to find the highest value that cannot be expressed in using 3x plus 4y format. Now this is true for even higher values. For example, if I have a number like let's say 7x plus 5y, now I'm going to do 2 things here. 7x plus 5y equals to 60. How many possible solutions? I'm going to solve that one also. Second question I'm going to do is 7x plus 5y. What is the highest number that cannot be expressed in this format? Both these things I'm going to solve right now. First, 7x plus 5y equals to 60. So let me start with the highest value. 7x plus 5y equals to 60. So let me start with the highest value that I can take for y. So 12 into 5 and I will take x as 0, y as 12 and I will get an answer here. And the next value for this 12, what I need to do is I need to subtract by 7 and for this I need to add by 5. So that 5 7s are 35 and 7 5s are 35 are offset. So here the next value is 5 and the next value here is 5. So and beyond this, if I keep going further, what I will be getting is I will be getting a negative value. So therefore no further solutions possible. I'll go and verify this. 7 5s are 35. 5 5s are 25. Do they add up to 60? Yes. So how many natural number solutions are there for 7x plus, not natural number, whole number solutions, because 0 is also part of our solution. So how many whole number solutions are possible for our 7x plus 5y equals to 60? There are 2 whole number solutions possible. If negative number solutions are also included, then this keeps going until infinity, and this side also it keeps going until infinity. There will be infinite possible solutions, which is why we will not consider the negative integer solutions. We'll only focus on either whole number solution or natural number solution. If you're asking me what is a whole number solution, I will include this solution and this solution, and I will tell you the whole number solution will be 2. If you ask me only natural number solution and whole number solutions are not possible, then I will say the answer is just 1. So depending upon how the question is framed, we can go and identify the answer. And here, what is the highest number that cannot be expressed? Let me go and write the numbers in columns. Let me go and write in 5 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'll at least have to write until, let's say, 35 to 40 or 18, 19, 20, 21, 22, 23, 24, 25 and 26, 27, 28, 29, 30. Just 2 more rows. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So now I filled in 5 columns. Now let me go. I filled in 5 columns. So let me go and highlight all the 7 multiples here. So this is 7 multiple, so that can be expressed. This is 7 multiple, that can be expressed. This is 7 multiple, just using 7x, I'll put y equal to 0 and I can express. This can be expressed, this can be expressed, and with this what I have done is I have expressed at least 1 values in all the columns. Now if I go further, what will happen is, like, every value here can be expressed by let's say, how did I come to this value? I just took 3 7s and keep adding 1 more 5s, 1 more 5s and 1 more 5, and you will be able to express every other subsequent values in this column. Similarly, here also I can go ahead and express every subsequent values here, every subsequent values here, every subsequent values here, every subsequent values here. What about the rightmost column? Will I be able to only express from 35? No, because we have a 5y format. I will simply put x is equal to 0, and what we will have is y equals to 1, y equals to 2, y equals to 3, y equals to 4, y equals to 5, y equals to 6 will give me all these columns. So now if you go ahead and see what are the numbers that cannot be expressed, the numbers that were not highlighted. So what is the number that highest number that has not been highlighted? So until this everything is highlighted. 30 is highlighted, and 29, 28, 27, 26, 25, 24 are all highlighted. The number that is not highlighted is actually 23. So 23 is the highest number that cannot be expressed in 7x plus 5y format. So this way we have learnt both these types of problems.